That's about enough boring theory for now. We're going to have a bit of fun in this final video where we look at optical illusions. Optical illusions are simply fun, not least because they perplex us somewhat. We're wondering what's going on. And while some people like to explain optical illusions, I think they can also just be enjoyed. But there is something to learn from optical illusions. They show us a lot about the constraints under which vision normally works. And they show us that we can produce startling effects simply by setting up the display or the thing we're looking at in just the right way. So we'll start with an old chestnut here. If you look at this 5x5 chessboard with the green column on it, you can see two squares labeled A and B. Those squares are actually the same shade of gray, but they sure as heck don't look it. What I'm going to do now is I'm going to cover up everything except those two squares. Here you go. And now you can see that they are actually the same shade. And you can also see a little trick that was used. One of them has a light colored font, making it appear a little darker. The other has a dark colored font, perhaps making it appear a little lighter. But if we put them back in their context, it's not at all obvious. You can't see that they are the same gray shade. But now, think why that might be sensible. What you're looking at looks like a three-dimensional scene in which an object is casting a shadow. That's very much a real-world situation. And if vision is for anything, it's for the real world, right? In the real world, shadows are absolutely part of things. Lighting conditions change all the time. And if we couldn't maintain some kind of perceptual constancy, as light conditions vary, we'd be hopelessly lost. The sun would change and we'd be trying to figure out everything again. So what this illusion exploits is the fact that providing you with information that suggests a real-world situation with varying lighting conditions is enough to make you interpret what you're seeing as if it were that kind of real condition and not an artificial example on a screen. Okay, I teach this section on optical illusions every year, and I had just taught it in 2015 when this dress came out. And I think it's 7 years later, 8 years later, I think the dress is still famous enough that you probably still heard of it. It broke the internet. Absolutely broke it. Someone posted this dress on the internet, and people were divided as to what color the dress is. Now, some people see this as white and gold, and some people see this as blue and black. I have to be careful here because I can only see this as white and gold. And the other one is blue and black. Yeah, it just seems crazy to me. But when people started chiming in on this, we had a self-organized real-time experiment because everyone was saying what they saw. And so we got judgments of this from literally millions of people. And it turns out half the people saw it one way and half the people saw it the other way. Very few people could see it both ways. So I'm on team yellow and gold, and that turns out to be wrong. I mean, there is a right answer here. And the right answer is whatever color the dress is. What you're looking at is a really crappy photograph. That's the right answer. It's a really crappy photograph that doesn't give you much hint about how it's lit, so it's difficult for you to interpret. Remember, the previous illusion gave you lots of clues as to what you were looking at and misled you like this. This gives you no clue for interpreting it. And this is one attempt to show how the same dress can appear differently depending on whether it's illuminated in yellow light, as on the left, or in blue light, as on the right. And yellow light seems to be the right interpretation. I don't know, it breaks my brain too because I'm on one side, but half the people are on one side and half the people are on the other. Let's leave the dress behind. I must admit, it's not my favorite, but it was a very impressive one. Okay, here's a fun one. This one uses the standard trick of very many optical illusions, which is to make you behave as if you were in a subject in a visual psychology experiment. You're to stare at a fixation cross. We already saw that weird things happen when you keep your eyes still. So what's going to happen is that in succession, these purple dots are going to wink on and off, so that there's always going to be a hole and the hole's going to move around. But while you're looking at it, if you stare at the fixation cross, that's not what you're going to see. What you're going to see is a green dot that comes out and eats all the others. Let's have a go and see, does it work? Now, obviously, I can't tell what works for you and what doesn't work, but I find that to be quite bizarre. So seeing under these conditions where you stare at a fixed point is slightly pathological, and it's not clear that such seeing is relevant to how we normally get by in the world. This is one of the major limitations of those experiments which sit someone down, tell them not to move, and then present images to them. We're so used to images, they greatly influence even how we think about seeing. I want to show you now an example which is kind of fun. This is a view of Dún Laoghaire Harbour, taken in 2008 during a sadly now gone festival. It was the Festival of World Cultures. It was a wonderful time in Dún Laoghaire. And this is the view from space, and what we're going to zoom in on, and we're going to zoom in from a height here on a little bit of the East Pier, where I think you can see there's someone has done a drawing. Yes, you can. Look at that drawing. It's a huge drawing. It's a huge drawing which someone has done on the pier. But we're looking at it from above and we can't really see what it's supposed to look like. This is what it's supposed to look like. Quite astonishing. An enormous vista opens up with a chasm that seems to go way, way down. Just to remind you, from above it looked like this. And this is absolutely fantastic. This is an example of anamorphic art. And anamorph is a special kind of image that can only be viewed from one particular position. Now, as it happens, I saw this in the flesh. Didn't look like this at all. I was on the ground standing beside it, but you could make it look like this. And the artist had helped you out for this. He'd provided a stand with a ring. And the way to make it look like this was to place your head so that you were looking through the ring, close your other eye, and not move. There's a familiar theme coming here, isn't there? Staying still and not moving. Under those conditions, it did indeed appear like this, but as soon as you opened your second eye, or you moved, the illusion disappeared. This art is slightly confusing because we're so used to photographs. This art looks best in a photograph. It's something that looks better in a photograph than it does in real life because it requires static, not moving, monocular, one eye viewing only. In other words, it treats you as if your eye were a camera, something we have explored. Now, it's fantastic work. Street art, pavement artists do this around the world, and they produce fantastic illusions, but they rely on this confusion between static monocular viewing, which is the kind of viewing you would be doing if the eye was a camera, and engaged, embodied in the world viewing, in which case the illusion goes away. Well, if this is the Rolls Royce of illusions, that's a pretty good one. It's a lot of work to make. This is one that I'm sure you'll think is absolutely boring. This is, you can imagine Victorian kids opening their Christmas presents and finding the boys' book of really simple visual illusions there or something. This one won't be in it. It's such a chestnut. It's called the Müller-Lyer illusion. And for most people, it seems that the two horizontal lines here appear to be of different lengths, but they are actually of the same length. Duh. Why are we even interested in such a boring, it must be said, boring illusion? Well, this has been known for a long time, and it was assumed that the reason why the illusion happens, has something to do with the physiology of the visual system. So we've emphasized the weird effects that happen when you hold still, close one eye, stare at a fixation cross. It was assumed that this is trading off something to do with very low level properties of visual processing, if you will, in the brain. But it was found that the reason this happens, or not the reason this happens, but the strength of this illusion depends not on your physiology, but on your culture. And isn't that strange? Now, this was found by performing what's almost never done, performing this psychological experiment. The psychological experiment asks you to say, is there a difference? Yes, there's a difference. And then there's a way to get to measure the strength of that difference by asking you to show how much the shorter, apparently shorter line would have to be stretched to be equal in length to the apparently longer line. So we can measure the strength of this effect. And there's an unfortunate thing about scientific psychology, which is 95% of scientific psychological experiments have been done on students of American universities, usually themselves psychology students, usually undergraduates. That's kind of frightening, isn't it? An awful lot of what we think we know about people, at least to the extent that scientific psychology tells us about people, is known from this weird group of very strange people who are undergraduates, psychology undergraduates in American universities. Well, in this case, they went beyond that normal pool and they went to people in a lot of different places, largely distributed across Africa, although I think there's a few other ones in there. We've got Uganda, Congo Republic, Nigeria, South Africa, Kalahari Desert, Senegal. So it's all Africa except for Central Australia and US state of Illinois. Now, the state of Illinois, the US contribution to this, those are the standard subjects used in psychology experiments. These were at Northwestern University in a suburb of Chicago, and they are typical of the kind of person who takes part in psychology experiments, but they're not at all typical of human beings. They had by far the greatest perceived effect. So the graph on the bottom right shows the strength of the effect. A big bar means the illusion is very strong. It shows differences between male and female, between adults and children, which we're not interested in. But the biggest one there is from those people who are usually taken as if they were representative of humanity. Everyone else had smaller effects. And for some people, those effects didn't occur at all. They were two groups. They were the San Bushmen from the Kalahari Desert in South Africa and South African miners. What they have in common, in fact, what they represent as an extreme, is they don't live in a world surrounded by vertical surfaces with carpentered edges. Now, you and I do. If you look around you, look how many surfaces there are around you which meet at right angles. The corner of a room, the construction of a desk, even your computer. The whole world is full of right angles for people who live in a particular culture. This illustrates the issue very, very well. And you can see how if you live in a world in which engineers, carpenters, builders have arranged that there are very many surfaces that meet in right angles, then you're going to meet patterns of lines that resemble those lines used in the Miller-Lyer illusion. Furthermore, those are good cues to depth perception. You can see that you can tell the difference between these two images. You can see in one case there's a distant corner and the walls are coming out towards you. In the other case, we have the same line, but the walls are receding. So for people like us who live in highly carpentered worlds, those particular configurations of lines are useful information. For people who don't live around such surfaces, they're not, and they don't display the illusion. So we always have to be careful about how we generalize, and this is a good illustration of the shortcomings of a psychology developed on rich American students. Here's another old classic. You all know this one, but maybe we can give it a new spin. The thing in the middle is called the Necker cube. And if you stare at just the Necker cube, you can see it in one of two ways, which are illustrated on the right and on the left. What's important about this is that the lines on the screen are the same, but using the power of your mind, you can flip it from seeing it one way to seeing it the other way. Try it out yourself. Make sure that you can see this cube, first of all, as it's shown on the left, in which case the bottom left-hand corner is on a front face. And can you see it as on the right, in which case the bottom left-hand corner is on the rear face. Now use the incredible power of your mind to flip it, and then we're going to try a harder one. This is a very famous one. This dancer appears to be spinning. No real dancer does this. She's bobbing up and down off the floor. If you were looking down from above, would you say she's spinning clockwise or counterclockwise? You probably have a good idea, but can you make her spin the other way as well? Because like the Necker cube, what you're seeing can be interpreted in two completely different and mutually exclusive ways. This dancer can be seen as spinning clockwise or counterclockwise. If she's stuck for you and you're not managing to make her switch, it is difficult. Let me give you something that can help you. There's the same dancer. Now, if you look at the wood on the right and then look at the dancer, you can see she's spinning counterclockwise. If you look at the one on the left and then look at the dancer, you can see she's spinning clockwise. So with this little bit of visual help, you can see it. Can you do it now with the awesome power of your own minds? Can you make this dancer reverse direction? Okay, that's enough of the dancer. Illusions are great fun, and every year people come up with new illusions. There's a website called illusionoftheyear.com that has probably 10 years of competition entries every year producing new optical illusions. Usually optical illusions. There's a few auditory illusions in there as well, which is really interesting. And if you're browsing through them and looking at an illusion, always ask yourself what you can learn from this. Is it asking you to view things in a very rigid manner? An awful lot of illusions require this stare at the fixation point or static monocular viewing, or they give you a limited view of things in a way that's highly artificial compared with natural viewing conditions. So it's a good idea to have fun with illusions, but they can inform us, they can enliven our questioning about the rich questions of seeing. Now, I feel guilty for having only talked about vision in this section on perception. There's obviously far more to say, and we could go on and we could discuss hearing and smell and taste and touch and all kinds of things, but we just keep encountering puzzles as we do so. And I think it's more important to see that we think of ourselves as visual beings, but that there are mysteries harbored there, and we will no more have a single theory of perception or a single theory of seeing than we will have a single theory of mind. We need multiple models. That's the main lesson, I think.